So hi there. Good evening to everyone. First and foremost, thank you very much for attending this webinar. My name is Anas. I'm from Cybernet Systems Malaysia. So as you all know, today's webinar is going to be about the digital engineering for construction industry featuring Ansys. If you have any questions at any point of this webinar, feel free to drop the questions on the chat box, and I will try to answer all of them at the end of this webinar. So here is the agenda for today. First, I will talk a little bit about Cybernet systems, and then we are going through the introduction, some of the demands and challenges in construction industry, and then we will see what is digital engineering and its benefits in construction industry. And then we continue with the introduction to Ansys, a little bit of overview of what Ansys is and what kind of products that Ansys have to offer. And then we go on with some of the Ansys capabilities for construction industries, a little bit analysis examples, and then I'm going to tell you our services here in Cybernet Systems. And then finally, we will wrap up everything with the Q&A session. Now let's start with a little introduction about our company. Established in 1985, Cybernet System has been providing CAE solutions and IT solutions through product sales, contract analysis, consulting, and software development for over 30 years now. We have developed a partnership with more than 20 companies, mainly in the United States, including Ansys, Synopsys, and Symantec. The sales subsidiaries of Cybernet System consist of Cybernet China, Cybernet Taiwan, Cyfam, which is based in Korea, and of course, Cybernet Systems Malaysia. Here, as you can see, Cybernet Systems has been working with numbers of group companies around the world for both sales and also development. Our development subsidiary include Noesis, MapleSoft, and Symmetrics. And of course, our sales subsidiary, like I mentioned before, consists of Cybernet Japan, China, Taiwan, Korea, and also Cybernet Malaysia. So a little introduction about Cybernet Systems Malaysia. Cybernet Systems Malaysia's Sdn Bhd office is in KL Ecocity, which is located in Bangsar, and has been around for more than a year now. Cybernet Systems Malaysia was established in November 2018 as the fourth subsidiary in Asia, after China, Taiwan, and Korea. Our business here mainly revolves around CAE solutions, IoT and big data solutions, and also professional services or engineering services. Our partners up until this point in time include Ansys, Synopsys, and many others. Like I mentioned before, Cybernet Systems provides all sorts of solutions to meet our customers' needs. Those solutions are CAE solutions, which give a total support of a CAE utilization in various fields. And also the main application areas here in the CAE solution include mechanical system, fluid system, control system, optical system, and also electrical systems. And then also we have the AR and VR solutions. So basically include the application area around general purpose visualization, AR and VR, and also medical imaging. Then we have the big data solutions, IoT, digital twin, and AI service, IT solution, and of course, engineering service. Our engineering service is basically a group of experts that helps engineers solve issues. The main application areas include a consultation, the MBSE professional services, and contract development and analysis. So before we get into how digital engineering can help to improve construction industry in several ways, let's highlight some of the demands from the end users and also challenges faced by construction industries nowadays. So now let's take a look at some of the demands and the expectation from the construction industries by the end users. So these are some of the important aspects, in my opinion. First, perhaps the most important aspect that needs to be taken into consideration when designing or building construction is perhaps safety. Since the first industrial revolution, safety has been deemed to be the most important aspect in every industry. As the world getting more and more advanced, the demand for a higher level of safety standard keep on rising as well. Therefore, the task of designing any kind of construction become more and more complicated and more challenging. Next is to create a more environmentally friendly buildings and construction. Nowadays, every industry is required to comply with a lot of standards and regulations that evolves around environmentally friendly theme. For this, the construction industry requires to be clever in tackling some of the environmental problem during the entirety of a project. It includes being smart in the choice of material use, maybe being smart when designing the building itself, logistics, so on and so forth. For example, the use of composite materials instead of traditional materials, and also the inclusion of, for example, natural ventilation in a certain part of a building. And finally is to improve human comfort. When designing a building, how well a person inside the building feel can be a deciding factor whether or not there will be any occupant inside the building at all. Now, this factor subsequently affecting the whole project at the very end, and thus becoming an important factor to be taken into consideration. Now, next, we take a look at some of the challenges currently faced by construction industry. Now, these challenges have been around for quite some times now. The common problems such as streamlining construction crew management and also labor shortage are still a headache. But apart from those, there are some other issues that industry needs to tackle as well. The first one will be the technology adoption in construction industry. When we compare how well does industry adopting new technologies, construction industry seems to be lagging behind compared to the other. As proved by the manufacturing industry, technology adoption opens up new opportunities for the industry to improve their way of working, subsequently boosting their productivity and ultimately improve their efficiency. Now, next, let's talk about material costs. Now, in 2018, some of the key material for construction rose almost 10% from previous year. According to the Associated Builders and Contractors, raw materials costs rose by 2.2% in June this year. Throughout the history, there usually have been just three mainstream options when it comes to structural construction materials that are aluminium, wood, and steel. Now, these problems do make the use of composite material in construction becoming more and more relevant. Although most composites are indeed initially more expensive than traditional materials, it offers a huge advantages over these traditional materials and has a lower overall cost of ownership and, of course, many other benefits as well. Next, another challenge faced by construction industry is, in fact, the planning process itself. And project planning is the most crucial stage in any project. Proper plan subsequently reduce any sorts of downtime or delay during the construction phase. Therefore, properly planning a project can be time-consuming as well. Understandably, construction industry is a highly dynamic with a lot of unpredictability. This is due to the fact that a lot of different factors can influence the construction process and cause all sorts of problems. And finally, the innovation in construction industry or the lack of it. It almost similar to the first point, but for a different outcome. Since the 70s and 90s, The adoption of CAD and BIM was the last significant technological innovation in construction. Like I mentioned earlier, the demand from the end user does make for a more complicated task that require more than just a traditional way of solving a problem. Now let's dive into what does it mean by digital engineering and how it can be beneficial for construction industry. Now, by definition, digital engineering is the advanced computerization of systems engineering practices. We can think of it as the art of creating, capturing, and integrating data using digital skill set, from drawings, 3D models, all the way to the simulations. Engineers are increasingly using the advanced technologies to capture data and craft design in a digitized virtual environment. Now, for today's webinar, we are going to focus on one aspect of the digital engineering, and it is the computer-aided engineering, or CAE. Now, CAE is part of the broad definition of digital engineering. So basically, CAE focuses on creating a virtual world of which simulating a real-life problem. Now, unlike many people think, CAE actually goes beyond the analysis and development stage. CAE actually defines the entire product engineering process, from initial design creation, virtual testing with sophisticated algorithms, all the way to the maintenance process. It allows a dynamic testing process to support the engineering process by numerically simulating the physical properties of a product or design in various conditions and environment without having the need to make a physical prototype. Now, type of physics simulation include in CAE finite element analysis, or FEA, computational fluid dynamics, or CFD, multi-body dynamics, optimization, digital twin, and so on. There are several ways that construction industry can take advantage from these types of analysis. So nowadays, getting an access to a powerful, high-performance computer is not a big of a problem anymore compared to, let's say, 10 years ago. With that level of accessibility, I believe that every industry, including construction industry, should be able to use a computer simulation software. Now, with that said, here are some several benefits of CAE. The first one actually is construction design can be evaluated and refined using computer simulations rather than a physical prototype testing, therefore saving money and time. What CAE can offer is to help engineering teams manage risk and understand the performance implications of their designs. Like I mentioned before, when the highest level of safety is required, CAE allows the engineers to simulate almost every situation, leaving no room for errors. Next, CAE can provide the performance insights earlier in the development process when design changes are less expensive to make. Predicting faults and failures are important in construction. With CAE, these failures can be predicted way before it even happened in real life, when the construction has already taken into shape. Next, with CAE, multiple design consideration can be done effortlessly. With CAE, the design decision can be made based on the impact of performances. Parametric study allow the user to identify the important variable as well. Plus, the speed of which the user can study multiple design parameters and calculate the outcome automatically really speed up the decision-making process, that's ultimately helping in reducing the total planning time. And lastly, CAE also can predict the performance and failure of the construction in real time. with the digital twin, actually, digital twin is a powerful new way in predicting failure in real time. Basically, digital twin can create a virtual twin of the actual construction and provide its performance in real life, in real time, helping in predicting failures and making a necessary action. Now, CAE has been around for a long time now. Since the beginning, Ansys has been providing one of, if not the most powerful and advanced CAE software of them all. Now, Ansys specializes in simulating a highly complex problems, delivering accurate results while providing an easy-to-use operating environment. Founded in 1970 by a man named John Swanson, Ansys Inc. is a global public company based in Canonsburg, Pennsylvania. It develops and markets multi-physics engineering simulation software for product design, testing, and operation. Now, as you can see on the slide here, those multi-physics include almost every conceivable physics analysis you can think of, ranging from a simple structural analysis all the way to a system simulation. Now, for 50 years, Ansys has been the class-leading multi-physics simulation software provider. Now, due to that very fact, Ansys now has been used worldwide with over 45,000 global customers. Ansys is also used in a wide range of industries, including automotive industries, electric and electronics, aerospace, and many, many more. As I said before, Ansys provide multiple physics simulation for every type of need. Now, the physics include a mechanical solution, which the analysis included under the mechanical solutions are static structural analysis, dynamic analysis, impact analysis, heat transfer analysis or thermal analysis, fatigue analysis, and so on. Next, we have the fluid solutions. The analysis included are general purpose thermal fluids analysis, rotating mechanical fluids analysis, and so on. And then, of course, we also have the electronic solutions, which include electromagnetic field analysis, signal integrity, power integrity, and electromagnetic interference analysis. Next, we have the design solution. The design solution is mainly for designers and CAD users. This is done using the Ansys product called Ansys Discovery. And then lastly, you also have several additional options that included under the Ansys solution, which include a parallel computing module, material data selection library, and so on. Now, let's take a closer look on how does Ansys work by looking through this next analysis. Now, for this one, we have a model of a truss bridge. Now, we were using Ansys Mechanical 2020 R2, which is the latest Ansys Mechanical software right now. As you may already know, structural and vibration analysis are part of the mechanical solution. Now, as for the license for this type of analysis, we need to have at least mechanical premium. Now, basically, there are three types of license for Ansys Mechanical. They are Mechanical Pro, Premium, and also Enterprise. With Mechanical Pro being the entry-level license, and Enterprise is the top-of-the-range license, which include everything under the mechanical solution. You can check out on the Ansys website for full license capabilities. Now, as for the type of analysis included in this particular case, we have a structural analysis, model analysis, and also response spectrum analysis. So basically, the objective here for this case is to study the deformation and stress imposed on the truss bridge under a seismic load. Now here, as you can see on the screen, is the analysis workflow for this particular case. We started with a structural analysis to determine the pre-stress condition of the truss bridge under its own weight. And then we coupled a model analysis to the static structural analysis to determine the natural frequencies and mode shapes of the truss bridge. Model analysis is actually very important to determine the critical mode shape to be used on later analysis. Finally, we coupled the response spectrum analysis to the model analysis to determine the stress and deformation of the truss bridge under a seismic load. Now, this type of case made easy thanks to the ability of Ansys to link multiple analyses together. Now, this way, the user doesn't have to manually key in the data from the previous analysis to the next one multiple times. Thus, save a lot of time. So, material used for this particular case are structural steel and also asphalt. Ansys have the ability to allow the users to key in any type of material using its engineering data. Therefore, if the users have a material data at their disposal, they can easily key in those data inside Ansys. And then next, we get into the meshing of our model here. The users can have a variety of mesh control. For this particular example, the global mesh was set at 40 millimeter, while a certain part of this model was meshed locally with a 30 millimeter of element size. Next, in the static structural analysis, we have the standard Earth gravity as one of the loading conditions. So basically, the whole model was subjected to a gravitational force. Then we fix the both end of our bridge right here to basically fix the whole structure into place. Next, in the after we've done setting up our loads and boundary condition, we continue with the calculation. Now, the time needed for the calculation depends on several factors, including the numbers of elements of the model, the CPU speed, and also the numbers of cores that you are running with. As for the static structural analysis, we want just to quickly study the deformation and the stress of the bridge under its own weight. So here, as we can see, the maximum deformation is around 0.7 millimeter, while the max equivalent stress here is around 76 megapascal, which is under the max yield strength of the material that we are using. Therefore, in this condition, we can say that the bridge is actually safe to use. Next, we continue with the model analysis. Because we link this analysis to the static structural analysis, this model analysis takes into account the stress from the previous analysis. Now, as for the loads and boundary condition setup, none is needed because we've already coupled it with the previous analysis. Here we can see the mode shape and the frequency of the bridge. Here is the example of the animation of one of the modes, which is the mode shape 3. As you can see, happened at the 22.325 Hertz. So next we move on to the next analysis, which is the response spectrum analysis. Now, response spectrum analysis is basically a method to estimate the structural response to short, non-deterministic transient dynamic events, such as earthquake. This particular seismic data sample that we are using here was gathered from a sample from Savannah Riverside disaggregated seismic spectra. Now, from the model analysis, we know that the effective mass is the highest in y direction. Therefore, the seismic load that we apply to our structure here are subjected in y-axis. Now, as for mode combination method, we are using Rose method. It is because the space of the modes are closely spaced together. And of course, in Ansys, different methods such as SRSS and CQC method can also be used depending on the model. Then finally, after running the calculation, we can see the results of the deformation and stress imposed on the bridge with the inclusion of seismic load. Now, note that these values of the deformation and stress are on top of the values that we get from the static structural analysis. Now, in this case, under the seismic load that we just applied to our structure here, we can say that the bridge is still within the safe side in terms of structural performance. So now let's continue with some more examples of Ansys capabilities. For next part, we are just going through the results of the analysis and which Ansys product that we were using. So here we have the first example here, we have a fatigue analysis. This analysis is basically done to study the durability of a structure and its components. For this particular analysis, we were using Ansys Mechanical. Almost the same like before, we were using vibration analysis, to be specific, harmonic response analysis, to see how long does it take before the structure fails. Note that the model that we are using here is actually a quarter of an actual model. So you can imagine that this actual structure is symmetry in the XX plane and also YZ plane. This way, we can save a considerable amount of simulation costs because basically we are just cutting the whole model into 4, therefore cutting the simulation cost into 4 as well. Now, as for the loads and boundary conditions, a point mass was attached to the structure to simulate the weight applied to the structure with the inclusion, of course, the standard Earth gravity. So here are the results from our analysis. On the left side, we have the stress from a static structural analysis before harmonic loads was applied. And on the right side is the result of the stress imposed on the structure after we've done the harmonic response analysis. Now, as you can see, due to the vibration input, the stress on the structure increased drastically. Now, mind you that for this particular example, the harmonic loads are exaggerated a little bit, basically to simulate a worst case scenario. Now, after we've done with the harmonic response analysis, we can start calculating the life of the structure using a fatigue tool. Now, this particular tool is included in the Ansys post-processing. Therefore, it did not require an additional analysis cell. From the previous analysis, we know that the maximum amplitude occurred at a frequency of 22.929. Here, as you can see. Using that information, we can calculate how long does it take before the structure fails. Now, as you can see, certain critical part of the structure fail almost immediately, while the longest time that certain parts of the structure can survive was around 43,000 seconds. With Ansys, we can also choose to view the results of a specific components of the structure. Now, in this case, we see that the bracket failed. This right here, the bracket failed after 20.9 seconds. So next here we have the explicit dynamic analysis. First, let me explain briefly about the difference between implicit and explicit dynamics. Now, basically, implicit and explicit refer to two types of time integration methods used to perform a dynamic simulation. Implicit method usually used when the problem time magnitude is relatively large, for let's say about 1 second to 10 seconds, something like that. While explicit method is used when the problem time magnitude is really, really small. We are talking about a few milliseconds and even microseconds in some cases. So there are three products within Ansys that can use for explicit dynamics. Those products are Ansys LS-DYNA, Ansys AutoDyn, and also Ansys Explicit Dynamics. In this particular example, we were using Ansys LS-DYNA. Now, this example is about a concrete pier impact test. Because an impact test happened in such a short time, explicit dynamic analysis is required. The model that we were using include the pier, which made out of concrete and structural steel for the rebar. For the model of the car, we just simplify it by making it a rigid body and add some mass to it. Of course, for more accurate representation, we can also use an exact model of a car with, include all of the components of the car with all sorts of materials that were used to make an actual model of a car. Now, mind you that if you opt to do that, the simulation time can be quite long. So as you can see right here, we can study the strain rate and also the crack propagation of which showing how the piers fails. And then, of course, we can also observe what happened to the rebar as well due to the impact from the car. So next, we've moved away from structural analysis to a fluid analysis. Here, as you can see on your screen, is an investigation of a flow pattern around and inside Putramos featuring Ansys Fluent. Now, Ansys Fluent is one of the most powerful CFD solutions that you can get your hands on. Ansys Fluent feature a Fluent solver that can basically calculate all sorts of fluid dynamics analysis. For this particular example, we wanted to know the fluid behavior around the Putramos. This type of analysis is great when the users are trying to take advantage of the natural wind to ventilate the interior of the buildings. Now, this video shows where the vortices occur inside and around the buildings. And then on the right side, the photos on the right side shows the velocity contour that show the wind speed around and, of course, inside the building as well. Where the blue area means velocity and the green area means higher velocity. Now, for this example, it's basically the same as the one before. But for this particular example, we would like to study how the fluid behave around a series of buildings, simulating a small region of high-rising city. Now, from this analysis, we can determine which region was excluded from the wind and which buildings are most affected. If you want, you can also perform a structural analysis using the data from this CFD analysis to study the integrity of the building under the wind load, which brings us to the next example. Now, this is an example that showcases the fluid structural interaction capabilities of Ansys. Now, Ansys is capable of doing a fluid structural coupling analysis. You can do either strongly coupled analysis or weakly coupled analysis. Strongly coupled analysis means both fluid structural analysis was solved simultaneously, while a weakly coupled analysis solves the problem one analysis at a time. Now, in this particular example is one of the weakly coupled analysis of a windmill. First, we studied the pressure on the windmill surface by using the Ansys Fluent. Now, from the data that we get from the Ansys Fluent, we can easily couple it to the static structural analysis to determine the stress and deformation of the windmill. Now, still with the fluid dynamic analysis, here we have the investigation of the effect of solar radiation to the indoor temperature of a cafe, featuring Ansys Fluent. Now, the investigation was done to investigate the indoor temperature, which was influenced by the solar radiation. Now, this investigation helps to understand the design of the interior of the cafe more easily. This investigation also helps in predicting the indoor temperature of a certain room inside a building before it being constructed. So basically, ultimately, by doing this analysis, we can understand more about the indoor temperature of a certain room, thus helps in maximizing the thermal comfort while minimizing the energy consumption. And then finally, let's take a look into the science of material by using Ansys. This is a microstructure homogenization analysis and also structural analysis featuring Ansys mechanical and multi-scale sim. Let me briefly explain about what is multi-scale sim. In essence, multi-scale sim is an add-on software to Ansys that can evaluate a material property of a composite material without having to perform a physical material test. It can be achieved by performing a homogenization analysis to a model of a microstructure, as you can see on the slide here. Now, for this particular example, we have a composite of epoxy resin and a glass fiber running through it uniaxially. Basically, what happened during the homogenization analysis is a series of uniaxial tension and pure shear tests, as you can see on your screen right here. Now, as a result from the homogenization analysis, the users can evaluate the microscopic material response as stress strain curve, which is then used to evaluate the equivalent material properties. So this is the result from our homogenization analysis just now. As you can see, we can determine the composite's Young's modulus, shear modulus, Poisson ratio, and also its density. Now, from here, we can export this data to Ansys engineering data, which the latter can be used to apply to any sorts of structure that we choose from. So next we move to a static structural analysis using the material properties that we've just got from the homogenization analysis via multi-scale sim. So this structure right here was made out of material that we've just analyzed just now. Now, like any of the structural analysis, we basically wanted to study the stress and deformation of this structure. Now, from this structural analysis, we can later compare the structural performance of the root structure with different type of material used. Now, as you can see on the screen right here, our composite material that we made just now perform better in terms of maximum equivalent stress compared to the structural steel and also the aluminum alloy. Plus, the composite material is at least 4 times lighter than the structural steel and at least 1.5 times lighter than the aluminum alloy. Therefore, from this analysis, we know that the composite material will be a better choice compared to the other two materials. Now, the possibility doesn't end there. You can make all sorts of material composition using multi-scale sim, comprised of whatever material that you choose from. And then you can run the homogenization analysis to get the material properties. And then using the material properties that you've just got, you can apply it to any structure model of your choice. Now, that's basically the advantage of multi-scale sim. So, to summarize, based on the examples of the Ansys capabilities that I've just shown you just now, I believe construction industry has a lot of opportunities to improve by utilizing the digital engineering. Now, with the ever-growing computer technologies that we have access today, I believe that CAE can help in boosting productivity, reducing downtime, and ultimately maximizing efficiency. By including CAE in the planning process, certain elements of the project can now be determined, thus helping in innovation and creative efforts for this industry. And then finally, before we go to the Q&A session, let me just briefly explain about our service here in Cybernet Systems Malaysia. Here in Cybernet Malaysia, we provide support for CAE deployment, including implementation, planning, education, consultation on policies, automation, and so on. Basically, there are two processes of our service. We have the startup support service, where consulting and milestone creation are done. And then we also have the construction of simulation environment, so on and so forth. We also have a operation support service, which comprise of different kind of support during the operation, such as a daily support service, consulting, sample data creation, automation, customization, so on and so forth.